The 2010 Hang Lung Mathematics Awards is governed by two committees. They are the Steering Committee, which is an advisory body that oversees the operations of the competition, and the Scientific Committee, which is the academic and adjudicating body. May I now invite Professor Sir James Mirrlees, Chairman of the 2010 Hang Lung Mathematics Awards Steering Committee and 1996 Nobel Laureate in Economics, to come up on stage to make some remarks. Please welcome Professor Mirrlees.
Michael Yuan and Ronnie Chan, Yao Xingtung, students, teachers, and other ladies and gentlemen here. I do enjoy this occasion each 2 years. I get to stand up here and say what a tremendous event it is. I don't have to do any serious work to make it happen, but a lot of people do have to do a very great deal of work. Few remarks about mathematics. All of you, of course, do mathematics to some extent. I've been wondering again, as I often do, quite what is the attraction of mathematics? What makes it so special? And it seemed to me there were 4 things I'd pick out today. The first, which I think hasn't been mentioned yet, is that mathematics is hard. Or to put it another way, it's a challenge. If you think about the human activities that mathematics, or doing mathematics, is like, then I think mountaineering might be a good example, where you have to work very hard and often go through things that at the time are rather painful, but you get your reward. And actually, a lot of the reward is what is painful. It's not just the view when you get to the top. But that view certainly matters. And mathematics is, I hope we all agree, a subject that does produce delight and beauty. I'd have to say that just as mathematics isn't always hard, it isn't always beautiful either. And I would have to confess that I've quite often been disappointed to find the arguments that lead to interesting conclusions involve a dull checking of many cases. It's just like toiling your way up through woods when you can see nothing and simply feel it's hard work. So mathematics isn't always beautiful, and it isn't always hard, and it isn't always fun, but I do think a lot of the time it is. And that's one of the things that makes us do mathematics, that it's in a quite direct sense enjoyable to do, but not for everyone. I hope that all of you who have been striving on these projects have indeed found that some of the time it can be fun, and a lot of fun, and I think that's a perfectly decent justification. But one is always driven to add at the end, yes, of course, mathematics is useful. Not necessarily very directly. Yao Xingtung pointed out a very striking and clear example of that. I was thinking of a different kind of example. I was delighted and honored to be put on the table called Newton. Now, Newton is a quite well-known mathematician from my own college in Cambridge, and so I like to feel an association with him. But I was reminded that Newton didn't spend all his time doing pure mathematics. He went on to be the master of the mint. He was in charge of the British currency, of keeping it sound. Now you will take that to be a rather simple application of mathematics, probably, but nevertheless, you may well think useful. But I have a warning. he became very enthusiastic about keeping the British currency, sterling, sound, to the extent of working very hard to get quite a number of people hanged for cheating on the currency. And I think if he had done some decent analysis of the incentives involved, he might have decided it wasn't necessary to go quite so far. Now, incentives is what I'm really interested in. That's the particular application of mathematics that I have found particularly fun, delightful, hard, and I think quite useful. I just came back yesterday from Stockholm, where I had gone to celebrate or help celebrate the award of a Nobel Prize to my long-term friend, co-author Peter Diamond, and two other economists. These three got the prize for what is called the economics of search. This arises from trying to understand what causes unemployment, which you will surely see is a potentially very important application. And I think it illustrates very well the way in which mathematics proves to be used. I don't just mean useful now, but I mean there's a particular way it's used. It's not just used to solve a problem which happens to have got formulated in mathematical terms. It's also used as a very important extension of our ordinary languages, which allow us to formulate concepts of the first importance. Probability would be a very clear example. Also, of course, many of the projects have been involved with interesting geometry and topology, particularly combinatorial geometry, which involves very interesting conceptualizations. Well, I suppose the simplest example of this that practically everybody can handle with reasonable ease is the idea of the coordinates of where you are and what the distance and direction is between different people. These are mathematical concepts. Probability clearly gives people a lot more trouble. And I must say I find plausible the explanation of the recent financial crisis that so troubled a large part of the world in the very poor understanding of probability. It's not enough just to define it. You've somehow got to get people to understand it. Anyway, probability plays a very important part, as you could imagine, in the theory of search. The uncertainties in pursuing a new job or looking for a new worker. Perhaps as soon as I've said words like that, it may suggest to you that, oh yes, we could begin to formulate that in equations, in symbols, in a mathematical model. And then, most important, out of that, there would be very precise questions that you'd want to ask. It might take the form of saying, right, what's the right level for the unemployment benefit? It's concrete questions like that that mathematics lets you address. There's a lot in getting there that has nothing to do with ordinary algebraic or geometrical manipulations. And I assure you that once you get into this theory, you will also get the other rewards of mathematics. That you can delight in the formulations, some of the neat results. The basic search equation is really quite attractive. If what I've been saying encourages the enormously able young people who have been involved in these projects to go on and continue to make use of the insights they've gained in all kinds of fields, then that's very much what I want to do. You know, of course, that there is no Nobel Prize in mathematics, but there is a Shaw Prize in mathematics, so you can aspire to these prizes. But my three friends who got the economics prize had all done mathematics as their first degrees. The work for which they got it was unquestionably mathematics as well as economics. And I think that's probably something that should further encourage you. Finally, I know you want to find out who's won, and you also want to hear some more about what people have done. And I think lots of fascinating stuff in the booklet that you have in front of you. But I do want to finish by not only saying well done to all of you students, but well done to all of you teachers. It is something that mathematics teachers somehow have a special place in my mind, and I believe in the world, because my maths teacher did an awful lot to make me whatever I am now. And that's clearly what has happened to you all here. So to the teachers, thanks. You're doing a great job.